Hey everyone, so I would just like to share with you where I'm up to on this project regarding the small range extender inverter for the BMW i3. I'm making a Vesc based control board for it. And I've run into a very strange issue. As soon as I power the thing on, and I start up the power supply, I'm only running it on 48 volts just now, but I've also tried putting 380 volts into it as well. As soon as I switch on the logic board, after a few seconds I just get three tick noises from the power stage, and the fault output for the gate drivers is active, which indicates that something has went wrong. And I could just demonstrate this just now. So if I switch on the 48 volt power supply and then switch on the logic board, you probably didn't hear that too well, but three tick noises came from it. And I suspect that's the Vesc doing offset calibration, because I probed the signal outputs on the oscilloscope, and that's what I get as soon as it starts up. So those are the gate drive signals for the high and low side of phase 1. So as soon as it starts up, it's doing some PWM cycles there, but none of that there indicates shoot through, which would trigger the fault like that. So I've set up my dead time to something quite excessive, like 2000 nanoseconds, and the switching frequency is 8 kilohertz, which is fairly typical for these inverters, and it still seems to do it. And I've noticed something else which is strange and unusual for Vesc controllers. The motor is very hard to turn, so it's not been sent to any PWM just now, but whenever I switch on the logic board and or the power supply, the motor is very difficult to turn. So if I switch this off, and then still hard to turn because the power supply is on. If I switch the power supply off, we just need to wait for the voltage to come down. That's super easy to turn. So the IGBT modules themselves, I don't think are shorted, so there's something else going on here, which is unusual. On the other Vesc based controllers that I've built, which are on my bikes, you don't get anything like that. Even with the battery connected or the controller even switched on, you do not get that unless you're actively giving a regeneration braking command with the left hand throttle. So I'm a bit stuck on what's going on here. I think there's some automatic feature being triggered somewhere on the power stage. I think this is probably another reason why electric cars get damaged if you tow them. I think it's because it shorts together all the phases when powered up for some reason. When it's in an idle state, it just like shorts the phases, which probably to prevent the thing from rolling away. I don't know, but like if you've got your 3H bridges, I think it just activates all the bottom 3 IGBT modules and just shorts all the phases to ground. So I think that's what's going on there. I've even tried it, when I tried it on the full 380 volts, it wasn't dramatic at all. It's just 3 small ticks like that as well. So it's very well protected. But that's not the only issue. I still have to figure out how to get the resolver on this working, but I'm obviously not going to be able to move past that. It's any time any sort of PWM gets sent to the power stage, there's just a single little tick noise, and then it doesn't respond anymore to inputs unless I reset the power. So if I leave the power supply off, then start the thing up, and then try and run a detection in the Vesc tool, there's just a single tick from the power stage and nothing happens. So there's something weird going on there. I don't know what it could possibly be. I'm going to read the data sheet for the gate drivers and try and see if I've missed something. So that's where we're at. Further issues to sort out are the SPI ADC, which is in here. I know it works because I ran a test program on this and I was able to extract the raw values from it, no problem. But it's when I start using direct memory access, which is really important for time critical stuff like this, it just crashes, so I get no USB connection, no flashing LEDs, nothing. So it seems that the processor runs into some unhandled exception there, so I don't know where to go from that. But yeah, the resolver IC, that's supported natively in the Vesc software somehow. I think I've got to enable it with some coding, because I don't see an option for it in the Vesc tool, so I've still got that to sort out. But yeah, it's a peculiar issue we've run up against these shorted phases as well. So I've asked about it on the forum, and I'm discussing it with ChatGPT 01, which has actually been quite helpful with this project. So the test program which is running on this, it got that right pretty much first time, so that was pretty good.